All right, let's jump right in. You know every single app on your phone? Every website you scroll through? Well, none of it just happened. It all started with a plan, a kind of blueprint. And that's exactly what we're going to do today. We're pulling back the curtain on how software really gets built. We'll be looking at all the different blueprints or models that engineers use to take something from just an idea to the app that's in your hand.
But first, let's start with a question that kind of haunts the tech world. Why on earth do so many software projects fail? I mean, they go way over budget, they blow past their deadlines, or sometimes they just plain don't work. The problem, at its core, is complexity, and that's exactly what these development models are designed to tame. So the solution is something called a software process model. Now, don't let the fancy name fool you. Simply put, it's the master plan. Think of it as the ultimate blueprint. It lays out all the crucial stages a project has to go through. Specification, which is just what are we building, design, how are we going to build it, validation, did we build the right thing, and evolution, how do we keep it running and make it better. It's the roadmap that keeps the whole team on the same page. So, where did this all start? Well, let's get into our very first blueprint, the classic, the one and only waterfall model.
The absolute best way to get your head around the waterfall model is to imagine building a house. You get this super detailed final blueprint before anyone even thinks about laying a single brick. You don't start putting up walls before the foundation is totally done, right? And you definitely don't put the roof on before the walls are up. Every single step is a separate phase, and it has to be 100% complete before you can move to the next one. There's no going back.
And here, you can see that rigid sequence in action. First, you define the requirements for the entire system. Then, you get into the nitty-gritty of the software requirements. After that, you design the big picture architecture, and then the detailed design for every little piece. Only after all, and I mean all, of that planning do you finally start coding. And only when all the coding is finished do you move on to testing. Each step just flows down to the next, and you can't swim back upstream, hence the name waterfall.
So what's the verdict on this method? Is it any good? Well, on one hand, that super rigid structure is actually great for making sure no one's wasting time. And it works really well if you have a team that's maybe a little less experienced. The planning is all handled right at the start. But, and this is a big but, the weaknesses are huge. It's just so inflexible. What happens if you're deep into coding and you suddenly realize there was a mistake way back in the requirements phase? Uh-oh. Going backward is a nightmare. It's super hard and crazy expensive. Plus, you don't even have a working product to show anyone until the very, very end. Talk about making your clients nervous.
Yeah, that inflexibility was a massive problem. It became pretty clear, pretty fast, that the industry needed a much more adaptable way to build things. This led to the whole idea of iteration.
This quote from our source material really says it all. The problems with the waterfall model created a demand for a new method which could provide faster results and offer greater flexibility. You can almost hear the desperation there. The industry was basically crying out for a change.
And that change was iterative development. The core idea here is actually pretty simple. Instead of trying to build the entire thing all at once, you just break the project down into small, bite-sized pieces. The team builds one little part, shows it off, gets feedback from actual users, and then uses that feedback to build the next piece. It all happens in these quick little mini cycles.
Let's switch up the analogy for this one. This approach is kind of like writing a book, but instead of writing the whole thing in secret, you write it one chapter at a time. And after each chapter, you give it to your editor to get their feedback before you write the next one. Now compare that to the waterfall way, which would be like hiding away for a year, writing the entire book, and only showing it to someone on launch day. You can see how getting that early feedback is a total game changer.
Okay, so we've got the rigid waterfall and the flexible iterative model. But what about projects that have really specific high-stakes needs? Like extreme quality control or managing just massive risks. Well, that's where some specialized blueprints come into the picture.
So first up, we have the V-shaped model. You can think of this one as an evolution of waterfall, but it's got this intense focus on quality control. Its whole philosophy is basically test everything starting from day one.
Just by looking at it, you can tell the V model is basically waterfall's cousin. It follows a step-by-step path, but here's the clever part. For every development phase on the left side of the V, there's a matching testing phase on the right. Planning for tests this early gives it a really high chance of success, especially for small projects where you know exactly what you need to build. The downside? Well, it's just as rigid and inflexible as waterfall. If anything needs to change midway through, you're in for a rough time.
Okay, next up we have a model that's really designed for the big leagues, the spiral model. This is the blueprint you pull out for those huge, complex, mission-critical projects. We're talking aerospace, defense systems, the kind of stuff where failure is just not an option.
The heart of the spiral model is this repeating four-phase cycle. A project literally goes through these phases over and over again in spirals. You start with planning. Then you do a really deep risk analysis where you might even build a quick prototype just to test your riskiest ideas. From there, it's on to engineering, the actual building and testing, and finally, evaluation, where the customer looks at what you've made. And then you start the next spiral, building on everything you just learned.
And this is where the name of the model is just so perfect. As you complete each cycle, you're making progress. That's the angle changing as you go around the circle. And with each new spiral you start, the project gets bigger and more expensive. That's the radius of the spiral getting wider and wider. It's a brilliant visual map of both your progress and your budget.
So the trade-off here is crystal clear. That massive emphasis on risk analysis makes it incredible for those huge, critical projects. But all of that analysis, it requires some seriously specialized experts and can get very, very expensive. This is definitely not the blueprint you'd use for a simple little app.
All right, finally, let's look at a model that has a completely different philosophy behind it. Extreme Programming, or XP for short. This isn't just about a process. It's really about creating a culture. It's built from the ground up for speed and intense collaboration.
And you can really see that culture in its key practices. Forget about massive planning sessions that take months. XP is all about small, frequent releases. It champions some pretty wild ideas, like test-first development, where you literally write the test before you write the code to pass it. It pushes for intense collaboration with things like pair programming, and even wants the customer physically in the room for constant, instant feedback. The focus here is all about people and being able to adapt on the fly, which makes it a totally different beast from the other models. So, we've seen the rigid planner, the flexible iterator, the quality fanatic, the risk manager, and the speedy collaborator. Which of course brings us to the most important question of all. Which one of these blueprints do you actually choose?
At the end of the day, there's no single best answer. It's not that simple. The real takeaway, the thing you have to remember, is that it's all about picking the right tool for the right job. So look here, this breaks it down pretty clearly. If you've got a product that's been around for a while, maybe with a less experienced team, the strict structure of waterfall, it might actually be perfect. But what if you need tons of user feedback? Then you're going to want to go with iterative. Building a small, super well-defined system, the V-shaped model and its focus on testing is a great fit. Now, if it's a massive, high-stakes, super expensive project, Spiral is pretty much your only real option. And if you just need to move fast with a small, tight-knit team, XP is definitely the way to go. You see, every single one of these blueprints has its moment to shine.
And that really just leaves us with one final thought. Every piece of software you use, from your banking app to your social media feed, was built using one of these blueprints, or probably some combination of them. So if you were the one in charge of building something new tomorrow, what blueprint would you choose?